Hello and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a concept builder on physicsclassroom.com in the topic of measurements in units, and it's titled Significant Digits. So perhaps the first thing you're wondering is what makes a digit significant? Well, let's start with that. Why are digits significant or insignificant? Let's say we take a look at this picture of this football stadium. Okay, how many people are in the stadium? Well, if we just glance down this picture, well, some of the people aren't even on the picture. You see it kind of cuts off some of them. I don't think there's any way we could tell. But even just glancing at it, we can't tell. There's just no way you could probably count through these. And so you estimate. You look at it and you go, okay, oh, that section probably can hold that much. It's about 60,000. Okay, so you look down at the picture, you estimate 60,000. Well, you didn't measure 60,000. You don't know that it's not 60,001 or 59,999, but it's between 50 and 70,000. And we need these zeros here. They're important, even if they're not significant, because without them, it just says 6 people. And obviously, they're more than 6 people. So we need the zeros to move that over to the 10,000s place. So they're important, but they're not significant because these numbers weren't measured. They're just holding a place. They could be a 1, a 2, a 3, a 4, 5, 6, 7, 8, 9. Each one of them could be any one of those numbers. Okay, so the only significant digit here would be the 6. The other ones are placeholders, pushing the 6 to the 10,000s place. On the other hand, they're not significant. On the other hand, if we went through and counted the ticket stubs, well, if we counted the ticket stubs, now we could get a much more accurate number, like 63,147. Okay, so now each one of these was measured carefully, and we know it's not 63,148 or 63,247. Each of those numbers was accurate. That is, these numbers, if they aren't exactly for sure, they're pretty certain. You're pretty sure that those numbers are accurate if you're going to write them. Okay, so if we just estimate, we'd use a number like that. That tells people we estimated these last digits. If we're going to measure them, then we put the actual number and put every digit that we actually measured. Okay, so one thing that tells us is non-zero digits are significant because we put zeros in when we're holding the place of the numbers. Okay, so all non-zero digits are significant. That's our first rule. So when are zeros significant and when are they not? Zeros are not always insignificant. So there are 3 types of zeros. There are leading zeros, captive zeros, and trailing zeros. Let's go through them one at a time. First, leading zeros are always insignificant. In other words, if the zeros come before the non-zero digits, they're just holding the decimal place, because without those there, 0.319 is different than 0.0319. And this first 0 is just so we don't miss the decimal. Okay? It's there by convention. Okay, so but to the left, always insignificant. There are only 3 significant digits here. Captive zeros are always significant. So if you have a captive zero, well, what's a captive zero? A captive zero is a zero that's in between 2 non-zero digits. So because the 3's on the left, the 1's on the right, the 0 in the middle is significant, this would have 4 significant digits. The 3, the 0, the 1, and the 9 are all significant in this case. Trailing zeros can be significant or not significant. Let's first look at when they are significant. Trailing zeros are significant if there is a decimal point. So here we see 2 examples of that. We see 410, and because we'd actually measured that 0 and we were sure it wasn't 411, it wasn't 409, we just add the decimal point there, and that's like a signal that that 0 is actually measured instead of just being a placeholder. In this case, there's no reason to even put these zeros if we didn't measure them, because 3.21, our calculator treats that the same as 3.2100. But when we look at it, we know that the only reason to have written those zeros is because we measured them. Whatever device we were measuring on, it was 3.21, but it was right on that line, so we have 0, 0. Okay? Trailing zeros are insignificant if there is not a decimal point. You probably figured that out, right? If they are significant when there's a decimal point, then they're not significant when there's not a decimal point. Okay, so that would look like this. Hey, we already saw that example. 60,000 people in the stadium. We were just estimating there's no decimal point, so all 4 of those zeros are insignificant. There's only 1 significant digit. So the apprentice level just has you count the significant digits. So let's go ahead and do that. So we see here that these are leading zeros, so they are not significant. Okay, there is a decimal point, so that 0 is significant, and captive zeros are always significant. So we have 1, 2, 3, 4, 5. That was not great way to mark those, but all 5 of those, the 2, the 3, the 0, the 5, and the 0 are all significant. We got 5. All right, maybe I'll underline them. Captive zeros are significant. Trailing zeros without a decimal point, not significant. Therefore, our significant digits are right here. That's 4 of them, 4, 3, 0, 1. All right, there is a decimal point, so trailing zeros are significant. Captive zeros are always significant. All right, and so we've got all of these are significant. We have 4 significant digits. All right, we have a decimal point, so that means trailing zeros are significant, and so all of those are significant, all 4, 9, 1, 0, 0. And that's what you do on the apprentice level. Count the significant digits, following the rules for the zeros, and you will complete the apprentice level. Now, moving on to the master level, it's about measuring. When we go to write our measurement, how many digits should we use? How many of the digits are significant? Well, let's think about what we know for sure. Okay? We know for sure it's going to be 2 point something, right? Because it clearly hasn't reached the 3 yet. Okay? And if we look at the lines in between, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means each one in between here is going to be 0.1. So that means the bigger line here in the middle is going to be it's going to be 2.5, but I forgot first I wanted to give you the rules here. The lines or marks on a measuring device determine the certain digits. So like we were just going to say that the 2, the 2.1, 2.2, 2.5, the 3, those are all going to be certain digits. Then we always want one more digit, one estimated digit. Okay. Second thing you need to know here is for the ones with a graduated cylinder, always measure to the bottom of the meniscus. See this curve that's caused because the water's more attracted to the glass than it is to other water. It's called adhesion. That creates this curve. Always measure to the bottom of the curve. That's why the lines are in the center here. I guess, anyways, yeah. So, but always measure to the bottom of that curve. I really should say to the center of the curve. When you use different substances, sometimes the curve goes this way, but you always measure to the center because there's really only a tiny bit of water on the side here that's right next to the glass, even though it looks like more because the glass is curved. So we always measure to right here. All right, now let's go back to talking about the numbers. So we have this line here, that would be the 2.5. Like we said, there were 10 in between, so each one's 0.1. That's going to be 2.5. So that means the next one's 2.6, and the next one's 2.7. So we know for sure, not only is it 2 something, we know it's 2.6 something, because it hasn't quite gotten to 2.7. All right, so those are our certain digits. We know for sure it's 2.6. Now we need to have one estimated digit. So we're going to go back and we're going to look at this and go between this line and this line, divide it in your mind into 10 parts. Okay? 2.61, 2.62, 2.63. It's hard to get that close together, but you get the idea, all the way up to 2.69 right before it gets to 2.70. Okay? And you estimate, well, that's about halfway in between, so it's very reasonable to estimate that at 2.65. Okay, so that is what we'd put for that one, 2.65, because it's estimated. We include that estimated digit. So as you're going through this, it'll have answers like 2.6. It'll have answers like 3 and 2. Okay, so make sure you're measuring all the certain digits, the 2.6, and then the estimated digit, which would give you the 5 in this case. Sometimes the estimated digit is 0. If the curve comes right down there, the estimated digit would be 2.60, because it could be 2.59 or 2.61, but it looks like it's right on the line, so we'd call it 2.60. But always include that estimated digit, especially if it's a 0. That's where the most students decide to ignore the 0 as though it's not important. If the measured digit is estimated to be a 0, then put it, because it was estimated. Same thing if it was down here. You'd actually have 2.00 if it looked like it was right on this line, because you know it's 2.0 because it's not up at 2.1, and then you're estimating the 0 in the hundredths place, 2.00. All right, and that is how you do the master level. Finally, that takes us to the wizard level. Looks like I forgot to have these come in one at a time. That's okay. So this is now we're going to do mathematical operations. So we have these numbers where we measured them out and we know to the hundredths place that they're accurate, or in this case we know to the ones place that they're accurate. By the way, the wizard level only has this type of scenario, okay? But I wanted to give you this anyways because it comes up a lot in physics. When you add or subtract numbers, I should say numbers, excuse me, keep the same precision as the least precise. Okay, so these are both precise to the hundredths place. If one of them was only precise to the tenths place, then your final answer would only be to the tenths place. Okay, so here we see we have, I'm going to write it out the way most of you are used to subtracting. Okay, like this, if we're going to do it to think through it. If you need to use a calculator, you can, but make sure you're very careful about the significant digits, because your calculator is not as smart as you. You got to be smarter than a calculator. It can do the math, but it doesn't know how many of the digits are important. So 1 minus 1 is 0, 2 minus 2 is 0, 2 minus 2 is 0, 4 minus 3 is 1. Okay, so if you wrote 10, you would be incorrect because you measured more carefully than that. You know it's actually 10.00. Okay, we knew the hundredths place here, we knew the hundredths place here, so we have to keep the hundredths place, even if it's a 0. Remember, zeros aren't any less important numbers than any other numbers. Okay, so we got to let the person reading our data or whatever it is know that all of those digits are significant. Okay, with that information, you'll be able to finish the wizard level, but listen for just a moment longer and we'll talk about multiplying and dividing. So when you multiply or divide, you keep the same number of digits, not the same precision as you did with adding, the number of significant digits as the value at the least number of significant digits. Okay, because when you multiply by something with a lot of places, that moves where this 2 affects farther down. So the key is that you're affecting 2 digits here, you're affecting 3 digits here. So even though your calculator reads this, you know that only the first 2 are significant. Now, since the next one's an 8, we'd round it off to 2600. This 5 right here would round up because the next digit's an 8. So we'd get 26,000, 26,000 is our answer. The reason is because the 2 after the number after the 2 and 62 could be anything. It could be 62.4 or even 61.8. And so that would affect this digit. And so therefore we don't really know what this is. And so we round off and let the person know these are the digits that we really know. And they're in the thousands place. The 6 is in the thousands place. So we keep the zeros so we know where the 6 is. We don't just drop them off because 26 would be very different and would not be very accurate. All right, so armed with that information, go ahead and see what you can do on the significant digits concept builder. If you have any questions, leave them in the comments below. And if you enjoyed this video, please click the like and subscribe button. And I'll see you the next time on the scientific adventures of Beard.